Hey everyone, welcome to this Learn It Education video, and in this series I will be solving some coding interview questions that these companies like Google, Amazon, Microsoft ask. So in today's video we will be solving this question. Given a list of numbers with only 3 unique numbers like 1, 2, 3, we have to sort that list in big O n time. So that's linear time. So we are only allowed to use one loop. So let's think about it, how we can solve this question. According to my understanding, they will be giving some list with 3 numbers 1, 2, 3, like 2, 2, 3, some list which contains only 3 and 1, 2 and 3. This will be the input and we have to sort it using some function, and the output will be the sorted one, which will be 1, 1, 1 is 2 times 3 and 3. So this will be the sorted array, and we have to do this in linear time. So which means we can't use insertion sort or selection sort or any other sort which has a big O n square or big O n log n complexity. We can use counting sort or radix sort that has big O n plus 1 n plus m complexity, which is good, which is linear time, and I hope they're also looking for something like that. There's a loophole in complexity thing, like when someone say big O of n, then that means this can be big O of n 3 times n or big O of 5 times n. So these things are also linear time and considered as big O of n. So that means we can use multiple loops but no nested loops. So that's a good thing. One thing I can do is, let me just erase everything. Okay, one approach I think is we can use some hash table or hash map. Okay, since there is no interviewer here and I only have this information, so I'm assuming that all input will contain these 3 numbers only. So one possibility is I can run a loop and start counting these numbers and store it in a hash map. So like I can make a hash map here and hash map in memory, and I can just point the pointer to the first element in the array and check if 3 is already in the hash map. If it's not, then add 3 and assign the corresponding value to 1. Then I can move the pointer. 3 is already present, so I just have to update this to 2 and then move the pointer here and update it to 3, and then here we reach 1. So 1 is not already present in the hash map, so add 1 and assign the value to 1. Then 2, we have to add 2 and assign it to the initial value 1, and then similarly we run over the entire loop, and finally we'll get the hash map with our 1, 2, 3 inside that hash map, and there are 4 1s and 2 2s. And then after that, what I can do, since I know that the array will only contain, I'm assuming the array will only contain 1, 2 and 3. So I can just run a loop from 1 to 3 and see that. So first the array loop will start with 1. So I'll just go to 1, and the lookup time of hash map or hash table is big of 1, so I don't really care about that. So here 1 is 4 times, so I've just, what happened again? Here 1 is 4 times, so I'll append 1 4 times, and 2 is 2 times, and 3 will be 3 times, and I'll just return this string, return this list. So in this way, the complexity of this algorithm will be n for this, where n is the length of the array, and 3 for this thing. 3 times n, I guess, because I have to loop 4 times for this, and 2 times for this, and 3 times for this. No, I'm so idiot, sorry. The complexity for this will be also n, because when for I equal to 1, I will go 4 times, and for I equal to 2, I will loop 2 times, and for I equals to 3, I'll loop 3 times. So in the total number of loops or iterations I have to take to complete this piece of code is n. So the final complexity of the entire algorithm will be n plus 1 or 2 times n, which, as I said earlier, is considered as big O of n. That's the algorithm, I guess. So let me just quickly code it in Python. Let me open my VS Code. Alright. So first of all, we have to use hash map. So I'll import the collections library. This will help us create a hash map. First of all, we'll make a loop that will run 0, 1 and 2. So that's for I in range 3. And then I'll make another loop that will append element the count number of times. So for some variable I don't care about, in range in the count of this thing. So this for loop will loop how many number of times that particular element is in the array underscore, and I have to append I in the sorted list. And finally, I'll just return the sorted list, and I'll run Today was a bad day, I guess. I'm making small mistakes over here. See, I'm distracted for some reason, and I don't even know why I'm distracted. Oh, where's 3? Oh, 5 plus 1. So this will give us the sorted array in 2 times and in linear time. This might seem that the complexity is n squared, but the total number of loops, the total number of iterations in this nested for loop is equal to the size of the numbers. So that's n. The complexity of this nested loop is n, not n squared. And the complexity for this is also n, because I know it's n. And yeah, the code is working. It's linear time, and I just solved a question from Google. I forgot to mention that this question was asked by Google in one of their coding interview challenges. So we just solved that question in linear time, or I just made one assumption that numbers will be 1, 2 and 3. So that's it for today. Guys, subscribe to my channel, like, share, comment, everything. And let me know how this new style is and what things I have to improve in my video. So that's it. Bye bye.